Okay, this is going to be our optional presentation, our first one of two in Module 3. And the purpose of this is for people who are still wanting some reinforcement on setting up and using Solver in these Excel programs. I fully expect there'll be people who just want to try it and work through it, but then this is here. I will go through a full example. We have this mid-module deliverable, which is something new for us in this in the course, and the purpose is to have you submitting something in the first week, just so I can get a look at it, because the purpose, as you look through the module 3, you'll notice you're asked to exchange these or to collect these for your whole group and do some comparisons across them. And the point is, I'll collect them first a week ahead of when you're due, and then if I get questions on how should we look at these, I'll have those things already ready, and maybe have even given each of the groups a little bit of guidance. That's my goal, is to look through and see if I can give you some specific points to focus on for each group. And so you'll be getting a little feedback. You'll obviously not be restricted to work from my suggestions. I just don't want it to be one of these things where you spend hours looking for something to focus on. So that's my point, is to try to jump in and join each group and maybe give you a quick start. So with that, that sort of explains why this is a little bit of a different procedure we're doing for this module. And let me just overview what's going on here. So this demonstration and getting started on this diet problem is to, just to provide you one view of setting up and solving the diet problem. A few notes. In this data that you get on the website, on the class portal from Canvas, the activity and constraints are reversed from how we've normally been setting up these models. The reason is it could be the case that instead of 10 activities or 10 foods, eventually you want to put 35 or 50 in there. As many, I think Excel will take up to 200. And so it becomes much easier to add things as rows than columns. At least that's our thinking. And of course, these data are collected from students, and so we cut and paste those in. And so it just gives us a change in the way this looks. And of course, the nice thing is it demonstrates to you, but when you do it, it doesn't really matter where things are located in the spreadsheet. As long as there's some logic that you can follow through, everything will work out. And you'll also see that in the transportation models of this module, that those are set up and they look different in Excel as well. Couple other things. All the constraints in this problem are minimum requirements. So obviously, if you were thinking about constructing a realistic diet, you would say, well, there are some things that need to be met at a minimum and some things that can't go above their maximum, but we're calling it a subsistence diet. Okay, and subsistence means we're really trying to measure not what someone would eat, but really how low can the cost of food go, right? What's this sort of envelope or under minimum, the lowest possible cost you can get? So one way to do that would be to try to, go through and do some statistical work, and that has certain merits, thinking about what's the cheapest way or the cheapest provision of protein per dollar versus sugar per dollar. But if you do any statistical work across multiple nutrients, you're going to find that you start talking about trade-offs. What's the average? What's the minimum and the maximum? What's the range? And so it ends up, you end up talking about those kind of analyses in sort of a modeling context. And so from that's sort of where Stigler jumps in way back in the day and says, look, let's put it in a modeling context and see how an optimizer focused only on getting the lowest cost possible to meet the minimum targets would put this together. And if you've read the paper as assigned reading by now, you were given the option to start reading it last week. And so that's why we would call it maybe a Stiglerian model. So it's really this sort of indexing of costs. Our task for the mid-module deliverable, you're asked to choose some foods out of that database, or you can go collect your own information. I mean, assuming you have a good idea of what the price paid was, you can just grab foods out of the cabinet and put those together, or ingredients, however you want to think about it. And then set the right-hand side values for constraints. I've given you a resource in the handout that would let you look for recommended daily intakes, and you can just use those as the minimums. I think it does say that you should target a middle-aged person, male or female, and those will generate some differences in the constraints. But you're also welcome to go out and look for other documentation that says what is the minimum, what's the requirement. The real thing we're looking for here is to set up and solve and report your solution. And like I said, I'll do a quick once-over on all those solutions that I collect and try to get some information, some feedback back out to each group that helps them with their actual assignment, because there are going to be a lot of things to look at. One is how different are the right-hand side values in the constraints, and some of you I may even give recommendations on sort of harmonizing your solutions, those kind of things. We'll just have to see how that all plays out, because all the groups could have something very different that would be beneficial for them to look at. And that's the way this food modeling, this sort of class project work is going to go from here on. Just to preview it for you, when we come to residency at Purdue, one of the final tasks you have will be to present some work that you've done. It'll be a short presentation, and your group will follow its own path. You'll come up with your own sort of design and a very specific question that you want to answer in the food nutrition cost context, and you'll have to build the constraints, and add either from that database or other data that you collect. You'll have to build out the data choices and report on that and sort of defend it in front of your class, and we'll ask you a few questions and see how that goes. And so this is sort of the part where you have this is sort of the kickoff on you and I interacting to sort of help you move through an entire process of posing a question and putting it in a model context. So I'm restricting the space down to food and nutrition so that we can have some kind of uniform presentations at the end. But once we get through this first step, it'll be an iterative process where you're asked to do a little bit more, and I'm trying to direct you, but also learn from you what might interest you more. With that, I'm going to pull up my spreadsheet and walk you through a quick overview of this data and how I would go about setting up and solving in Excel. Okay, I've opened this class data, or I think it's called fooddata.xlsx, and that's given to you. And now this data was collected by a bunch of undergrad students up in Wisconsin from a former PhD student of mine's class. So what does that mean? Well, the first thing is, if you get something weird, or you look at a food item and you see that it seems weird to you, then know that there was some student that maybe screwed something up. And you should check on that, and if it seems too weird, get it out of your data, because it could mess things up. This hasn't been completely vetted, but being able to identify those mistakes are something that's kind of important for you. So what is going on here? You see there's these long names and then abbreviations. I think these are for the variables. These long names give a longer description, and then here's the price, and then we have this blank cell that Dr. Rimble's left, and that's because the kind of model we're going to use, we want the activity cells right next to the price per unit, and then in starts the nutrition values. Now the nutrition values are for calories, fat, sodium, carbs, fiber, protein. Vitamin A, vitamin C, calcium, and iron, and those are all the things that are required by USDA or FDA or somebody to be listed on the nutrition facts of any food items that are sold. So it's easy data to get. And then pricing is easy because if you're at a store, it's easy to price. So I suspect what happened here was she sent students out to groceries, and they just took pictures of the nutrition facts, and then they came home and put them in Excel, and we collected this data. So there's a few things to keep in mind here. I'll talk about a little bit. Typically, the nutrition facts is put on a per serving basis. And so one of the places you might see a screw up is a student that put the per serving amounts on the right hand side, or on these nutrition values, but forgot to divide by the number of servings over here. And so with that, be on the lookout. I think a lot of them are correct, but this was one assignment that they were asked to do, and they got graded on it, but all the data got collected by some TA and just added together. So I think it's pretty good, and obviously we should always be looking at any data, because any of us are capable of inputting a number wrong when we do something. The other thing is that you can obviously collect your own, right? So if, like I said before, if you have some things that are interesting and you want to sort of get a measure of the cost of the nutrition in the last grocery trip you made, it would be pretty simple to snag those out of the bag or out of the pantry, and just if you have a pretty decent idea of what you paid, to do that as well. Okay, so a couple other things you might think of. These were all collected in sort of the same town, so any kind of inflation or those kind of factors shouldn't show up here, right? So Wendy's burgers, so listed here, Arby's sandwiches, in your town may be more expensive than these, but these should be relatively close to those. So that's the other part here, and that those kind of inflation effects should fall out of our model, right? So we may get inflated total cost values compared to some places, but the nutrition costs in a relative sense should hold up. Okay, let me jump over to my demo. So you're asked to collect some information. The easiest way would be to grab 10 or 12, whatever. But if you want to go through, maybe use some logic and say, well, I'm going to pick a few sweet items, a few meal ingredients, soup, some things that are ingredients for preparation at home versus away from home. However you want to do it, you can do that. I'm pretty sure I just collected the first whatever number here and pasted them over here. And so what I've done is, the first thing is I'm just going to replace that choice variables column with all zeros. Okay, so it was blank here, but I know there's my choice variables, so I'm going to go ahead and put them in as 0, and I actually put a little boundary around it. So I think you can use this exact demo as a template for yours. The one thing I will ask is that you don't use exactly the same foods. That'll make this boring quickly. So change these up, and so these abbreviations would be like my variable names, and this would be a way to remind me of what those go with. I have over here all the nutrition information, and I've set the right hand side values. Okay, so I'm doing a 2,500 calorie diet. There's no minimum on fat. The idea, and most of the nutrition recommendations say that you will get, if you're meeting all the other requirements, you're going to get the minimum required fat. The thing we watch for in fat is typically too much fat content in the diet. And also, obviously, if you have some knowledge on nutrition, the kind of fats that you're getting and the ratio that those come in, and we don't have that kind of detail here. I have a minimum amount of sodium, carbs, and fiber, and protein. And then for vitamin A, C, calcium, and iron, the nutrition facts only requires that they post the percentage of a 2,000 calorie diet that is met by a serving of their product. Well, that makes it difficult, right? I think sometimes these are posted in milligrams and micrograms. I don't even know what they all are. But they're minute measurement nutrients, And so what we've done is, instead of trying to come up with the quantity values, if this is given to us as the percentage of a 2,000 calorie diet, and it says you need 10%, or this contributes, the McDonald's Big Mac has 10% of the vitamin A needed for someone on a 2,000 calorie diet, I'm just going to scale it up. Since my diet needs to be 2,500 calories, I'm just going to say proportionately I'm going to need more vitamin A. And so instead of trying to hit 100 here, which would be the full 100%, I'm going to try to hit 125 on all these percentages. And that's just a way of sort of rescaling this data over here. With that, I should be ready to set up my formulas. And so I have a cell down here marked for my objective. And that will be the measurement of total cost of all the foods that I'm going to let Excel choose for me as the diet. So that means I'm going to be multiplying the column of choice variables by the column of prices, and then adding those together. That's a sum product formula. So let me input that as sum product, and then the first array I'm going to use is the dollars, or the price in dollars, and then I'll set a comma to separate for the second array, and that's going to be the choice variables. With that, I'll close the parentheses and hit enter, and then I can test that formula really quickly. I'm going to put a 1 there, and my cost should show up as 609. If I add another 1, then it should be 609 plus 519. Okay. So the next thing I need to do is add all the left-hand side of the constraints, and those are going to be the same thing, the same kind of sum product formula. So I want a 1 there to give me 1 times 1,090 and 1,090 to show up here. So let's go ahead and set that sum product formula. I'm going to go equals sum product as one word, open parentheses, and then I'm going to hit select the calories column, E3 to E16, comma, and I'm going to select the choice variables column. Now for this one, before I close the parentheses, I'm going to hit F4, and what F4 does is it puts those dollar signs around the cell locations and makes that absolute cell reference. So when I cut and paste, or when I drag the formula across all these other constraints that I need, that means that this won't move. This reference to this cell will stay locked here, while the other piece will be moving. It'll collect the fat information and multiply by choices, the sodium information and multiply by the choices. So let's see if we're getting this right. We'll hit enter, and we do get 1,090 there. And so the other thing I would do is just drag across, copy that formula, and I should get a repeat of the Wendy's Dave's triple row here, which looks like I'm getting, and so my formulas look correct. And I'll go ahead and set this back to 0. Okay, I believe I have everything correct. I have 0 versus 2,500, 0 versus 0, 0 to 2,000. So clearly I need some more activities, some activity levels. Instead of just testing out solutions, we're going to use solver. So I go to data, and I open the solver dialog. Now this solver dialog is already built in. It's already been set up, and I think in the demo you get it will be as well, but you should check it. So clicking here on the set the objective is B22, and sure enough B22 is where I put the cost information. It's been chosen to minimize, and by changing the variable cells, just copying, that's the same thing, D3 to D16. Now for the constraints, wow, it's going to be hard to move that. There it is. It says E18 through N18 are greater than or equal to E20 through N20, and I'm just going to go ahead and delete that out. Click add, and I'll start on the left hand side. So this is where we need the left hand side value. So even though it's on the top, think of it as the left hand side of an equation. I'll switch the middle to greater than or equal to, and then we get here for the right hand sides, we're just going to grab these values as cell references, and it looks like it was put in perfectly before. So the E to N cell row 18 versus E to N row 20. We'll click OK. We have the non-negativity constraints, that checkbox, make sure that it doesn't go negative for any of the food choices. A solver method is simplex LP, that's good, and so let's click solve. Okay, so it says keep the solver solution, I want to do that. And then over here it has the reports, and I'll just, if you're walking through this video with me, go ahead and click on sensitivity. We're not going to use it right now, but you'll be asked to when you get to the, I can tell you when you get to the assignment for this week, you'll be asked to report your sensitivity, so you might as well grab it while you're here. Click OK, and let's look at our solution. So anybody's watched me do one of these videos, I don't like a bunch of decimals, so I always cut those down to 2 usually. And you have what looks like just a wonderful diet here. We've got a crispy chicken sandwich, a Wendy's Baconator sandwich, and a Dave's Double. And that would give us the choices. It's going to be an expensive day of eating, $60 to meet all of our requirements. And down here we might start looking right away and want to find what constraints are binding. Well, we've got one there. And then a couple more right here. So we've got 3 constraints that are binding, 3 activity levels that are not 0, and that's where we'd start working from. So let's say that I decide from here I cannot afford $60 a day eating, plus I'm not sure I can afford 500 grams of fat and 8,000 calories a day either, just to meet my fiber, my vitamin A, my vitamin C. Now your first thought might be, well, just get a fiber supplement, a vitamin A supplement, vitamin C supplement, and see how it comes down. You can drop those out or see what those would cost and add those in, something like that. But really what the story of this model is, rather than thinking right away about scenarios to try to pull this down and improve the diet, look at what I have here. Mostly foods away from home and a few sort of quick make home meals. Well, it turns out none of these are strong sources of fiber, vitamin A, and vitamin C. And so if I want to try to fill out my entire nutrition from this, it's a very expensive way to meet some important requirements of our diet. So it's an expensive pattern, but it's a true pattern for these food choices, right? And so I think people that if you go through and make carefully selected food choices, look for things that will provide fiber at low cost, vitamin A at low cost. You can get this cost down with 10 foods or 12 foods, in the $3 to $5 range pretty easily. But what everybody needs to do when their first round and sort of their discussion, their paragraph is say, why is this cost so high? Well, out of these 12 foods, none of them are very cheap sources of fiber, vitamin A and vitamin C, and you can see that by how just violently we're overshooting all the other constraints in the model. So they're relatively cheap sources of calories, fat, sodium, and carbs, and even protein, right? We way overshot this one, but they are just not good sources here. So there's an obvious strategy for lowering this, but this is really sort of the cost index of trying to eat well while selecting from only these foods. Now, the other thing that we're sort of trying to learn this week is that adding any food, adding any choice here, can't make this go up, right? So if we add a second choice that is some relatively good fiber source, it will obviously drive this cost down, and the amount would depend on how valuable it is, how good it substitutes into this model. And so that's really going to be that's one of the themes of Lab 1, adding choices and seeing when costs do and don't change. But knowing that as you add choices here, you can only be improving your options. You can only be moving towards lowering cost. You can't be going the other direction. With that, I think that's enough. I think you're only asked to just do some reporting on this and maybe a little bit of a summary. So don't forget, activities, optimum, and the binding constraints all should be part of what you sort of describe in your summary. With that, we'll sign out of here and let you work on your own.